Welcome to the first episode of the CrackSense Project Data Stories 360 podcast. I'm Sandra Kolaric, Junior Communication Manager at Foodscale Hub, one of the partners in the CrackSense project, and I'll be your host for this episode. Today, I'm joined by Luana Centorame, R&D Manager and Agritech Specialist at Agrobit. Together, we'll explore how digital tools, data-driven decision-making, and smart technologies are shaping the future of orchard management, with a special focus on cherries and the challenges growers face in real-world conditions. To start us off, it would be great to hear a bit about your background. Could you tell us a bit more about your professional journey so far, the kind of work you are involved in today, and what first motivated you to move into digital agriculture?
Okay, good morning to everyone. First of all, I'd like to thank Sandra and the entire CrackSense team for the opportunity. My name is Luana Centorame. I'm an agronomist and soon to be a PhD in agricultural sciences. My journey into digital agriculture started at university, where I first began experimenting with the approach of precision agriculture, initially during wet harvesting in central Italy, then using a smart sprayer in vineyards. And I had the opportunity to pursue a PhD in agricultural engineering, focusing on the application of AI to drone-based image analysis. And today I work as a R&D manager and Agritech specialist in Agrobit, where I'm involved into the development of a mobile application, iAgro, and applying AI and computer vision to the analysis of drone imagery.
Okay, thank you. With that background in mind, let's zoom in on the reality in orchards today. Cherry production is still often managed through exercise-based and manual practices. From your perspective, what are the main limitations of this approach today?
It's a very good question. I think that experience-based agriculture is still extremely widespread and deeply rooted, even more in cherry production, which is a relatively niche sector. From my perspective, one of the main limitations of this approach is that it strongly hinders generational turnover because of a great deal of valuable knowledge that is in farmers' hand risks being lost rather than transferred or formalized. For example, building an historical data set that is one of the key factors of digital agriculture. Another critical aspect is labor cost. Relying heavily on manual practices makes the final products, for example, sweet cherries, less competitive on the market. And lastly, I think that this approach tends to account only to a limited extent for example, for spatial and temporal variability in the field. So today it's a pivotal factor for improving efficiency, sustainability, and also decision making for farmers.
Thank you. This brings us nicely to the Open Agri project and your role within it. Within the Open Agri project, you are involved in SIP10 and the development of Smart Cherry. For listeners who are not familiar with Open Agri or the SIP structure, how would you describe SIP10 and the core idea behind Smart Cherry in some simple terms?
Yeah, SIP10 it's for us Smart Cherry that addresses the lack of affordable and crop-specific digital tools for cherry growers. Even if for more in detail for in protected geographical indication, like for example, cherry of Lari in Tuscany, Italy. These farmers must meet strict quality, traceability, and sustainability standards while facing limited connectivity or economic constraints that prevent them from adopting costly digital tools. designed for larger crops like cereal or vineyards. So, as Agrobit, to bridge this gap, Smart Cherry introduces a smartphone-based decision support system tailored specifically for cherry growers. So, it empowers cherry growers with data-driven insights on irrigation, fertilization, and pest control, pest management, without requiring expensive hardware or continuous internet access.
Okay, and what were the key design choices you made to ensure the system works in real orchard conditions, especially for farmers with limited connectivity or resources?
Smart Cherry was specifically designed as a low-cost solution around an existing mobile application that is iAgro. I think that there are three most important design choices that we made. The first one was to rely entirely on the smartphone, making the system accessible to everyone, because I think that right now everyone has a smartphone. So it doesn't require a dedicated infrastructure, complex machinery, or additional hardware. A second key decision to ensure was to ensure that the app works well also in poor connectivity condition that is very common in rural areas. And farmers can make image acquisition and a first step analysis that can be performed even without internet connection. The last but not least, another crucial aspect was bringing together several essential functionalities like weather forecast, canopy, and digital twins analysis linked to bigger and water stress maps, alert system for disease and pests, and also the reporting tools. This integrated approach helps farmers make the informed decision using an all-in-one solution, all-in-one through the smartphone.
Okay. Let's connect this now to another major challenge growers face. CrackSense focuses on fruit cracking risk through multi-scale sensing, environmental data, and decision support systems, including work-ons with cherries. From your own experience working with cherry growers, how visible is this problem in practice, and how do farmers currently try to manage or anticipate it?
From my experience working with cherry growers, fruit cracking is a very visible and well-known problem, especially in the days leading up to harvest and after sudden rainfall events. In Italy, for example, farmers are fully aware of the risk and still manage it using a combination of choosing varietal tolerant varieties and careful irrigation to avoid water stress. There are also other solutions like rain covers, but they are still costly for small and medium-sized farm. Overall, many decisions such as anticipating harvest or adjusting management practices are still made based on experience-based agriculture. What is often missing is a data-driven approach that can quantify, for example, tracking risk in real time by combining environmental condition, fruit development stage, for example, and orchard variability, of course. And this is exactly where decision support systems like those developed by CrackSense can make a real difference.
This creates an interesting link between the two projects. Both Open Agri and CrackSense use precision farming approaches, data-driven decision support, and advanced sensing technologies, but they focus on different outcomes, so to say. So you already mentioned how this can be complemented. Well, do you have any more ideas how these two approaches can be used to improve orchard management and decision making?
Yeah, I think that OpenAgri and CrackSense has high complementary rather than overlapping approach, but they focus on they both rely on precision farming, but focusing on different interconnected levels of orchard management. I mean, OpenAgri focuses more on the structural and physiological understanding of the orchard. For example, monitoring canopy development, vigor, water stress, and spatial variability over time. And this type of data supports strategic and operational decisions such as input management, long-term optimization. On the other hand, CrackSense focuses on a very specific but economically important critical risk that is fruit cracking by combining multi-scale sensing with environmental and weather-driven data. So I think that when combined, these two approaches create a more complete decision support framework, and the orchard level insights provided by OpenAgri can supply the baseline condition and variability context, while CrackSense can build on this information to deliver targeted risk assessment and timely actions.
Okay. And to wrap things up, let's look ahead. How do you see orchard management evolving in the next few years?
This is a great question. I see orchard management becoming increasingly data-driven, of course, and predictive rather than reactive. And I think that is the biggest difference between experience-based agriculture that is reactive to a problem and the digital agriculture solution that are predictive. For example, which is the risk to have Monilia on cherry in the next 5 days. So we predict something. And in the next few years, we will move away from isolated tools towards systems that combine multi-layer data, for example, environmental data, plant physiology, canopy level, and field level variability into a single decision making framework. And of course, the artificial intelligence will play a growing role because it translates complex data into actionable insights for farmers. At the same time, I think that smartphones and low-cost sensing technologies will continue to lower the barrier to adoption because this is one of the biggest bottleneck of digital agriculture. Smartphone, I think that will make a digital agriculture more accessible, even for small and medium-sized farms. Another key shift will be the focus on risk management because of extreme climate events and pest and disease outbreaking, supported by early warning system and predictive models, of course. So I think that orchard management will evolve towards a more resilient system.
Thank you. This sounds very interesting, and I hope it will be in that way. And that brings us to the end of this episode. We're very grateful to Luana for taking the time to share her insights and be part of this conversation. Stay tuned for more CrackSense Data Stories 360 discussions coming soon. And for updates and project news, visit us at cracksense.eu. Thank you, everybody.
Thank you very much.